Hi everyone. Today we're going to learn a new type of factoring. We're going to do what's called factoring a quadratic, or basically for today we're going to factor x squared plus bx plus c. And b and c can be any numbers in that. So first of all, let's start with a quick review. The first type of factoring that we learned was called factoring out common terms. And what we learned is that it's basically the distributive property but backwards. Now yesterday I reviewed how to multiply binomials with you. And the reason I did that is because the next type of factoring that we're going to learn is that problem backwards. So what we're noticing is we went through this whole unit on multiplying polynomials, and now we're doing those problems backwards, and that's what we call factoring. So let's start with an example, not of factoring yet, but of actually multiplying, and then we'll look at our question and we'll work together on how we can do that question backwards. So if I was multiplying this question, remember what I do is I do the distributive property but twice. I start with the x. I say I'm going to take this first x and I'm going to distribute it. So the first thing I would do is x times x, which is x squared. Then the second thing I would do is x times 3. And that's positive, it's all positive, so that's positive 3x. I would put plus 3x. After that, I would distribute the 5. So I would do 5 times x, which is positive 5x, so I'll put plus 5x. And then I would finish it up by doing 5 times 3. And again, that was positive times positive, so it's positive 15. I'll put plus 15. So for my final answer, I would leave the x squared, combine my like terms in the middle. 3x plus 5x equals 8x, and then leave the 15. All right, so that was an example of what we did last unit and also what we reviewed yesterday. Now, I already told you what we're doing today. What we're doing today is we are starting with something like this. We're going to do what's called factoring it, and our answer is going to be x plus 5 times x plus 3. So let's look at this question, and let's pretend like we didn't know that. Let's say we are trying to end up with those two factors without knowing what they were originally, without knowing it was x plus 5 and x plus 3. So all we have right now, imagine all we have is what I circled in green. It says x squared plus 8x plus 15, and we need to come up with that original problem. So let's look at it one piece at a time. Let's start with the x squared. Now the x squared came from my first distributive property. It was the purple one. So x squared comes from doing x times x. That means I'm going to have an x here and an x here. Now, I'm going to skip to the end. Let's look at the 15 next. The 15 right here came from the red part, and I distributed the original one in color so I could talk about them easily. The red one when we did 5 times 3. Now, I don't know what those numbers are yet, but I know those two numbers need to multiply to give me 15, or to give me whatever number I see right here. But I don't know what they are. You know, well, I do know what they are because we did the problem. It's 3 and 5, but I wouldn't know that. I would say, well, is it 3 times 5? Is it 1 times 15? I don't know yet. And that's where the 8 comes in. The 8 is the only other number in this question. And you say, well, where did that 8x really come from? It came from 3x plus 5x. And where did the 3 and the 5 come from? Those are the two numbers I'm looking for right now. So in addition to multiplying together to give me 15, those numbers need to add together to give me 8. And that's how I would know it's 3 times 5. I would say I'm looking for two numbers that multiply together to give me 15 and add together to give me 8. And it's kind of like a number puzzle. When you're working backwards, you got to think of it like a puzzle. You have to come up with those two numbers that multiply together to give you 15 and add to give you 8. Once you realize it's 5 and 3, then you put a plus 5 on one of them and a plus 3 on the other, and you can see we got our answer. So that's kind of how we would work that question backwards. Let's put it into our notes now. So first of all, let's just make sure we understand what that word means. If I ask you to factor x squared plus bx plus c, where b and c are any numbers, so it might say x squared plus 2x minus 3, or something like that, any number positive or negative, it means to write it like that. You have two, what we call factors, which is a binomial in parentheses. The first one is going to say x, and that plus or minus means it could be a plus or minus. So it might say like x plus 5 for the first one, and x minus 7 for the second one, or something like that. That's what it means to factor. So what we want to do is just figure out what goes in those boxes. Figure out if it's a plus or a minus, and what number goes in there. And to do that, we're going to use that, what we just figured out on the last slide. We're going to say those two numbers must multiply to give you whatever number you see here, and add to give you whatever number you see in front of x. Once you figure it out, once you realize, like on the last one, once you realize it's a 5 and a 3, you just put the plus 5 on one of them and the plus 3 on the other one, and you got your answer. So here are some steps when you're first learning this process. That math puzzle part can be kind of hard. So I'm going to give you some steps that'll help you work through it. What I usually do at the beginning is I start with C. And I list all of the factor pairs of C, just like when we were looking for greatest common factor, except there's one little twist here. When we did greatest common factor, it was always a positive number. Now all of a sudden we have to do a different thing for positive versus negative numbers. And I'm going to do two examples today, one of each, so I can show you the difference between the two. But make sure you think about whether C is positive or negative. Then run through that list of factors and find the pair that adds up to B, whatever number is in front of x. And then those are the numbers that go in the boxes, that go after each x. If it's a positive number, you put plus that number. If it's a negative, you put minus. So let's go ahead and do those two examples. Here's our first example. We want to factor x squared plus 3x minus 18. And I say, well, you know what? I can start my answer right now. I can say, when I ask you to factor something, it means two different factors, two different things in parentheses. Each one starts with an x, and what I have to do is just figure out what comes after x. It might be plus some number, it might be minus some number. Now, once you've realized that, what we are looking for, we're looking for two numbers that multiply together to give you negative 18. Remember, that's a negative 18 because it has a minus in front of it, and that's important. It's not just an 18. And those numbers need to add to positive 3 because it has a plus in front of it. So everything that has a plus in front of it is a positive number. Everything with a minus is a negative. Now, I said eventually, you guys will probably get to the point where you can do this in your head. You can start thinking of it and be like, well, let's see, is it this times that? Does that add up to 3? You know, but we're not there yet. We are just learning this. So for the beginning of the process, I said, take the number you're multiplying with first. Let's start with that. Let's take the negative 18 and let's list factor pairs. Now, I want to slow down and talk about what I meant between the difference between a positive and a negative number. So this is a negative 18. If you're just thinking about the number 18, the first number pair I think of is 1 times 18. But 1 times 18 is positive 18, and we want it to be negative. To get negative, you have to have one positive number times one negative number. But then you don't know which it is. So for every pair of numbers you think of, you actually get two pairs on your list. So for example, negative 18 could be positive 1 times negative 18, but it could also be negative 1 times positive 18, because each one of those is a negative times a positive, and the answer is negative. The next pair of numbers I think of is 2 and 9, but then again, you're going to get two choices, because it could be, if you're ending with negative 18, it could be positive 2 times negative 9, or negative 2 times positive 9. The next pair of numbers I think of is 3 times 6. And again, it could be positive 3 times negative 6 or negative 3 times positive 6. And that's actually the end of our list. 4 does not work, 5 does not work, and we're back to 6. So let's look at each pair and see what they add up to. The top one, positive 1 plus negative 18 would be negative 17. That's not the one I'm looking for, because remember, if you look back at our original problem, I'm looking for the two numbers on this list that add up to positive 3. Okay, the next one down, negative 1 plus 18 would be positive 17. Neither of those work. Okay, the next one, 2 plus negative 9 is negative 7. Nope. Negative 2 plus positive 9 is positive 7. No. And see, when you're adding, it also comes in pairs. You also get the same number twice, one positive and one negative. Okay, next one down, 3 plus negative 6 is negative 3. That's close, but that's not our answer. See, we don't want it to be negative 3, we want it to be positive 3. So it's going to be the other one. Negative 3 plus 6 gives me a positive 3. Now, as soon as I find that positive 3, remember, that's what I'm looking for right here. Those are the two numbers that I want in my factors, a negative 3 and a positive 6. So what you do is go back to we already set up our framework for our answer. After one of the x's, put a negative 3. After the other x, since it's a positive 6, you put plus 6. And that's it, you're done. Box it up and you're done. One thing I want to mention, it doesn't matter what order you put them in. If you wrote the x plus 6 first and the x minus 3 second, that's fine. That's still the correct answer. As long as you have the right factors, it doesn't matter what order they are in. That's like saying, what's the difference between 2 times 3 and 3 times 2? It doesn't matter. The answer is 6 either way. Same thing here. X minus 3 times x plus 6 is the same as x plus 6 times x minus 3. But the work here, remember, I said it's kind of like a number puzzle. You guys are looking at the numbers in the question, which were a negative 18 and a positive 3. And you're saying to yourself, I need to find two numbers that multiply together to give me negative 18 and add together to give me positive 3. All right, let's do another example. This time we're going to factor x squared minus 6x plus 8. And I'm going to do the same thing. I'm going to set my answer up right now. I'm going to say I know my answer is going to look like this. I just need to figure out the numbers that come after each x. Now this time I am looking for numbers that multiply together to give me a positive 8 and add together to give me a negative 6. So let's do a number tree again, factor tree. I'm going to take a positive 8 this time. I'll even put the plus in front of it to remind me. And I'm going to do my factors again. Now, remember when we had a negative number, we said you always get two choices for every pair of numbers you think of. That's going to be true again. So for example, when I see the 8, the first thing I think of is 1 times 8. So let me just write that down. 1 times 8 is 8. But here's the thing. Remember, negative times negative also equals positive. So this could actually be negative 1 times negative 8. So no matter what, when you're doing this type of factoring, you're always getting two factor pairs for every pair of numbers you think of. When it was a negative number, like our last example, it was one of each. So you could say, okay, positive this and negative that, or negative this and positive that. Well, when you're factoring a positive number, you have to say, well, it could be positive times positive. That's the obvious one. But it could also be negative times negative. The next pair of numbers I think of is 2 times 4. And I say again, well, it could be positive times positive. 2 times 4 is definitely 8. But they could both be negative too. You could have negative 2 times negative 4 because negative times negative is positive. That's the end of our list. 3 doesn't work, and then we're back to 4. So let's see what they add up to. 1 plus 8 is 9. That's not what we're looking for. Negative 1 plus negative 8 is negative 9. That's not what we're looking for. 2 plus 4 is 6. That's close, but that's a positive 6, and we want a negative 6. So it's our last one. Negative 2 and negative 4 give me negative 6. So these are the two numbers I want, negative 2 and negative 4. go back and in either order, doesn't matter which one comes first, go back to your x's, put a -2 after one of them, and a -4 after the other. And you know that's your final answer. And remember, what you're really saying is we're doing multiplication backwards. You're saying if I did a multiplication problem and did x minus 2 times x minus 4, the answer would be x squared minus 6x plus 8. And that's what we're doing today when we factor. Now there's one last thing I want to mention about factoring, and that is that not every quadratic is factorable. And remember, a quadratic, that's the name for our x squared plus bx plus c. So if you're trying to factor and you list all of the factor pairs of c and you notice that none of them add up to b, then what you do is you write not factorable and move on. And let me just to kind of make up a quick example here. The last one we factored was x squared minus 6x plus 8. Well, let's say, for example, I'll just make a tiny little change here. Let's say instead of plus 8, we have plus 7. And you're supposed to factor that. So you go, okay, well, I'm going to do the same thing. I'm going to take my positive 7, and I'm going to make a factor list. 7 could be 1 times 7, or -1 times -7. And that's it. And those are the only factors of 7. So you go, well, let's see what they add up to. 1 plus 7 is 8. -1 plus, oops, that's supposed to be a -7. -1 plus -7 is -8. And you go, wait a minute, I'm looking for ones that add up to -6. None of them do. That's because this one right here is not factorable. So be aware of that. You might see some in the worksheet where you see some where you're thinking, okay, I'm going to factor this, and you make your list of factors and you find none of them add up to b. If you're confident that you didn't miss any factors, that you got your factor list right, and none of them add up to b, that means it's not factorable. The one other thing I want to mention real quickly, we'll look at this later in the year, you won't even see it yet, but notice the title of the section was called x squared plus bx plus c. There's no number in front of the x squared. In fact, if there is, if I put like a 3 here or something like that, that makes it a much harder question, much harder to factor, something we'll talk about a little bit later in the year. But like I said, for now, you won't even see that. There shouldn't be a number in front of the x squared.